High-quality cuts through steel can be obtained if you, the welder, know which cutting tip to select, how to adjust your flame, what flame angle to use, and the proper speed for the cut. To make a quality cut through a steel plate using MAP gas, just follow these simple operating procedures. First, set up your tanks and torch. Make sure your cylinders are fastened securely to a cart or a wall so they won't fall over. Now crack the valves quickly on the MAP gas and oxygen tanks to blow out dirt. Make sure the regulator inlet connections are clean. Then attach the regulators to the cylinders and tighten the connection nuts firmly. Be sure the regulator adjusting screws are backed all the way out. Now connect the green hose to the oxygen tank regulator and the red hose to the MAP gas tank regulator. The oxygen hose fittings have right-hand threads and the MAP gas hose fittings have left-hand threads. Then connect the other ends to the torch butt. Remember, red goes on the fuel and green goes on the oxygen. Now open the oxygen cylinder valve until the pressure is built up. Then open it all the way. Do not stand in front of or behind the gauges when opening the tanks, because the front and back plates on the gauges could blow out if they're defective. Using the same precautions, open the MAP gas cylinder valve one turn. Next, open the oxygen valve on the torch and adjust the oxygen regulator to the proper pressure for the type of job. In this case, 35 pounds per square inch. Continue to purge the oxygen for about 10 seconds per 100 feet of hose. Then turn off the torch valve. Now adjust the pressure of the fuel line to the proper pressure for the job. In this case, 7 pounds per square inch. Then purge the fuel line. By purging the hoses, you ensure that any mixture of gases left in the hoses is eliminated, so that there will be no flashback when the torch is lit. Now attach the cutting tip to the butt. The large center hole in the tip is for the cutting oxygen, and the small slits around the center hole are for the preheat flames. Once the equipment is set up, there are 5 factors that you'll need to consider before beginning to cut. The nature of the workpiece, the amount of oxygen pressure at the torch's tip, the proper flame for the job, the proper cutting speed for the job, and the proper torch angle for the type of cut. To light the torch, first crack the fuel gas valve about 1/8 turn. Then light the torch with a striker. Adjust the oxygen and fuel gas to the desired flame. Now slowly increase the oxygen until the yellow flame becomes blue, with a few yellow feathers remaining on the end of the preheat cones. This is a slightly carburizing flame. Twist the oxygen valve slightly and the feather will disappear. The preheat cones will turn dark blue and will be sharply defined. This is a neutral flame adjustment used most often in flame cutting. If you add more oxygen, the flame will turn light blue and the roar of the torch will increase. Also, the preheat cones will become shorter. This is called an oxidizing flame. Before selecting the flame which is suitable for the job, you may want to check the best oxygen pressure to use for the tip you've selected. In this case, a general MAP gas cutting tip. This simple test is performed only at the torch and not at the tank's regulator. First, put a low-volume, soft flame on the tip. Then turn on the cutting oxygen with the lever and vary the pressure to find the best-looking stinger. Low pressures give very short stingers and will break up at the end. As the pressure is increased, the stinger will become coherent and long. This is the correct cutting oxygen pressure for the tip you've selected. If your oxygen pressure is too high, the surface of the cut will be concave and may be notched. If low oxygen pressure is used, the cutting will go slowly. Excessive drag and slag formation will result, and a wide kerf often is produced at the bottom of the cut. After checking the oxygen pressure, you must consider the torch angle that would best suit the job. If you're going to cut ordinary plate thicknesses of 1/2 to 1 inch, keep the preheat cones about 1/16 to 1/8 inch off the surface of the work. To pierce or for fast starts, let the preheat cones hit the surface to give faster preheating. The angle of the torch will also affect the cut. Torch angle is the acute angle between the axis of the torch and the workpiece surface when the torch is pointed in the direction of the cut. If you're cutting light gauge steel up to 1/4 inch thick, use a 40° to 50° angle. This will cut much faster than if you hold the tip perpendicular to the plate. On plates up to 1/2 inch thick, increase your torch angle to 60 to 70 degrees and increase the speed of your cut. Plates over 1/2 inch in thickness should be cut with the torch perpendicular to the metal. You can tell if your cutting speed is too fast by the way the sparks fly from the bottom of the cut. If the sparks fly straight down or backwards, you're cutting too fast. On plate up to 2 inches thick, a high-quality cut will send a spark stream at a 15-degree lead angle in the same direction as the torch is traveling. The nature of the workpiece will dictate your cutting speed, as well as torch angle and flame structure. The quality of the cut will not only depend on these factors, but on the different workpiece surface conditions and plate compositions. For example, rusty or oily plates require more preheating and lower travel speeds than clean plates. Prepare the surface of a rusty plate by setting a large preheat flame. Then run it over the surface to be cut. This cuts away scale and passes extra preheat into the plate to improve the cut quality and to increase the travel speed. Now that you're familiar with travel speed, torch angles, types of flames, and the correct oxygen pressure, you're ready to evaluate your workpiece and begin your cut. The workpiece is a plate of 1/4 inch carbon steel, and a straight, clean cut is required. The best flame for the job is a neutral flame. Since the plate is 1/4 inch thick, the torch must be angled between 40 and 50 degrees, and the travel speed can be fairly fast. There are several methods of beginning the cut. To start at the edge, the most common method is to position the tip so that the preheat flames heat the top corner of the plate, while the cutting oxygen hole is centered over the corner. When the plate turns cherry red, turn on the cutting oxygen and start the torch travel. Cut for a distance equal to the plate thickness, in this case a 1/4 inch. Then pull the torch away from the edge, turn on the cutting oxygen, and begin traveling. By using this method, you'll be at normal cutting speed the moment the torch reaches the plate edge. When the shape or location of your cut precludes an edge start, you'll have to pierce the plate to begin cutting. One method of piercing involves moving the torch in a circular pattern, allowing the flame to touch the surface. When the spot turns red hot, slowly turn on the cutting oxygen while simultaneously raising the torch and beginning travel. An alternative method is to make a hot spot, then rotate the torch so that the tip is angled away from the direction of travel. Start the cutting oxygen, rotate the torch until the tip is perpendicular to the plate, then lift the torch and keep it moving along the line of the cut. As you continue your cut, make sure that your torch is angled between 40 and 50 degrees, and that the spark stream is at a slight angle in the same direction as the torch travel. If the sparks are falling straight down or opposite the torch direction, your travel speed is too fast. Try to maintain a steady speed throughout your cut. If the flame and molten metal spits back at you, your torch is too close to the metal, so raise the torch slightly. This cut is a good job for a beginner. The cut is straight, the kerf or distance between the edges is consistent, the edges are fairly sharp, and there is little or no slag remaining around the area of the cut. This is a poor cut because the top edge of the cut is melted. The preheat flame is too long. This cut is gouged at the bottom because the preheat flame is too short. The preheat flame should look like this. Other faults in cutting are caused by incorrect cutting speeds and maladjustments of the oxygen pressure. For instance, the top edge of this cut is melted because the oxygen pressure is too low. When the oxygen pressure is too high, the cut will be notched and concave. This cut also indicates the cutting speed was too slow because the drag lines are rough and uneven. If your cutting speed is too fast, the drag lines will appear rough. Remember, common cutting problems result from the incorrect adjustment of the preheat flame, oxygen pressure, and cutting speed. Also remember, thicker metals require more preheating, more torch angle, and slower travel speeds for good quality cuts. If you want to bevel or angle a cut, just use a piece of angle iron to guide the torch at an even angle. To extinguish the torch once you've finished cutting, close the fuel valve, then close the oxygen valve. Then close both cylinder valves. Next, open the fuel valve and bleed off the MAP gas. Then do the same for the oxygen. Finally, back out both regulator adjusting screws. Now quickly review the setup techniques to yourself.